My name is Louis Moreau and I'm a user success engineer with EdgeImpulse. The goal of EdgeImpulse is to empower embedded developers to build applications and solve a real problem with using machine learning on edge devices without having a PhD in machine learning. During this small workshop, you will learn how to build a movement classification model that runs on the Sony Spresense board, where we will compile the inference model so that it can run with a NuttX real-time operating system. Just as a reminder, Sony Spresense is a small but powerful development board with a 6 Cortex M4 microcontroller, integrated GPS, and a wide variety of add-on modules, including a camera module, a microphone, an accelerometer, and we are going to use the accelerometer on this workshop. This board is fully supported by EdgeImpulse, and you will be able to sample raw data, build models, and deploy your trained machine learning model directly from the EdgeImpulse studio. So yeah, we can get started. So the first thing you need to do is to flash the board with the default EdgeImpulse firmware. To do so, you can go to doc.edgeimpulse.com/docs/Sony Spresense. You will find a small tutorial on how to do that, including a video from Jenny. This is pretty easy. I've already done that. You just need to download the latest EdgeImpulse firmware. Make sure you have Python 3.7 or higher installed locally on your laptop, and then you just need to run the script, which is here on my laptop. Which is here. So you just double click on the flash here, Mac for me, but we have a Windows or Linux script as well. Once your device is flashed, you will see something similar to this, and you can directly log to the studio and get started. So if you do not have an account on EdgeImpulse Studio already, you can create an account. Here I'm just going to log in, and I will create a new project. So Sony Spresense tutorial. Create a new project, and you will arrive on this nice dashboard. First thing I usually do is to just make sure I selected the right board so that the latency and performance calculation will be calculated according to your board. Here, this one. And then you can navigate to the data acquisition tab. We have a useful tool to connect using web USB. If you do not want to use that, you can use EdgeImpulse daemon to connect to your project. Here I'm going to use this one. Make sure you use Chrome. I think it's also supported on other browsers. Yeah, I know Chrome, it does work. Let's wait for a few seconds. So now you can see your board. You have several sensors on the board. Let me show you. Here I've got the camera module. This is the main board, and then this is the extension board. So we were going to use the accelerometer, and I will try to just collect some data that we will use after to train our model, and we'll try to classify those movements. First sample will be up down, for example. Let's do 10 milliseconds, and then I will start sampling. So the up down movement will look like that. Up down. Here you can see the visualization of your accelerometer data. I will try to collect some more. Maybe another one. So 30 seconds is probably not enough. So I will pause the video. I will try to collect as well other kind of movements. Let me do that. try to collect right now another movement so that you can see the difference. So circle, for example. So we'll just draw circles in the air. Okay, I'll do another one. Well, I'll actually do 2 more. Another one. And usually it's also a good idea to have a unknown movement kind, so I will just move randomly the board. Here, another one. So I have 30 seconds in each class. Well, I will have 30 seconds in each class. I recommend to add much more data, but just as a demonstrating purpose, this should be enough. So this unknown seems to have like a regular pattern, so I will just delete this one because I'm not satisfied with it. It might look too close to the other up down or circle kind of movements. Okay, this looks more random. So now that you have your data, you can navigate to your to create an impulse. An impulse is a mix of digital signal processing and learning block, for digital signal processing blocks and learning block. Here I will leave those default parameters. I will add a processing block, spectral analysis, which is usually good. So let me just great for analyzing repetitive motion such as data from accelerometer. So that's more than fine with us. We have several other digital signal processing blocks. If you are using audio, you can use some MFCC or MFE. MFCC is mostly great for recognizing human voice, etc. But here for accelerometer project, we'll keep with the spectral analysis block. And then I'll use some classification, so keras, which is going to be a neural network that we are going to train. So we'll have 3 output features that our neural network is going to try to classify, so circle, unknown, and up-down. I save my impulse, then I can navigate to the spectral feature tab. I'll try to leave the default parameter by now, and just I will try to check if I can detect some clusters in my different movements. Usually when you detect different clusters, it's good because it will say that the neural network is likely to be able to classify the movements correctly. So here I've got some nice clusters. You can see the data are well split in this 3D visualization. So I'm kind of happy with that at the moment, and now I will move to the neural network. So what is important to see here is that you can start training your model and build some machine learning project really without being an expert in machine learning. So we just unlock all the capabilities for you as embedded developers, so that you can use all these advanced techniques. So accuracy here, it seems like I've got some pretty good accuracy. The model seems to be converging, which is good. And this seems fine. Let's check the accuracy in the integer, well, in the quantized model, because it's smaller. Well, for accelerometer data, it doesn't really matter because the difference is not really high. But for audio and for image classification, usually it does matter. The models are way smaller in quantized version. Just wait until the profiling is done. Good, we wait few more seconds and the accuracy and the confusion metrics should appear. So now it's profiling for the Eon compiler, which is something that Edge Impulse developed so it can compress the model one step further. So it has the same accuracy but has a lower footprint on the RAM and ROM on the model. So here, yeah, we have a perfect accuracy. Well, those kind of movements are not really hard to classify. So you can have like an overview of the confusion metrics. You can here, let me just check the incorrect ones here. So this is this movement. So over here, it kind of predicted a circle. Well, we can see a small pattern, but in the overall project, it's not really a big deal. Then you can just try the live classification. So let me connect my board again, and I will try to classify movements, and then we'll see how to build the device, build the model onto the device. So I'll start sampling right now, and I will start with the up-down movement. I can also like change and do some circle at this point, and it should like on the results just say, okay, the first rows were, well, the first samples were up down, so up down here, and then at some point we will change it to circles. So here that was in between. So maybe this messed because I changed the thing, but I would try to just do some other circles at some point. Just testing again. Start sampling, and I will just draw a circle here. Okay, interesting. So here it just recognize some unknown movements, and then at the end some circles. Well, we don't have much data in this project. If you want a really good accuracy in real life, I suggest you add much more data. This is not a problem. We will go to deployment so that we can deploy the C++ library. One thing that we are going to use here is to use directly the Sony Spresense binary, so we can analyze the optimization. So we can see the footprint. So this comes with so we packaged both the NuttX real-time OS with the Edge Impulse SDK. So it's going to create a mix of both. So it just brings all the capabilities together, and with this you have directly a binary ready to go. So I'll just build it, and then we will flash it on the device. So here we have several warnings. And you can also check on our GitHub page. Let me check where it is. Let me go back here while it's compiling. So if you're interested in directly compiling the C++ library, you can go to this web page, standalone example standalone inferencing. So it will just explain to you how to just compile the standalone C++ example using the Spresense exported SDK and the Edge Impulse SDK. It's not really complicated. If you do not have all the dependency installed, you can build the firmware just using Docker. It's way easier. Usually it's what I do. And then you can flash the device, and it should be able to run the inference directly on the board. And obviously you can modify this main.c++ file so that you can create your own application. So here we have the example on how to just flash. It's the same way that to flash the default firmware. And once you have that, you are ready to go. Open the Sony. Here, Sony Spresense tutorial. Let me open that. So V1. Let me flash it using the flash Mac command. Oh, I need to allow developer access, security and privacy. Open anyway. Yeah, just open the script, flashing the board. So right now it's flashing the board with the latest, well, with your custom model that you just developed. And once you're done with that, you can run the, we'll open a new terminal here. Maybe let me zoom in a bit for you. It's going to be easier to see. Now the board is being flashed. And once you're happy with this, saving package to NuttX. Okay. Okay, now it is flashed, so you can now run the Edge Impulse run impulse. Let me remove that. Let me zoom a bit here. And we'll use the Edge Impulse run impulse. So now the board is not moving at all. Let me just do some up-down movements. We'll see how you react. So up-down movements. Here the inference works. Let me try with the circle one, just before it had troubles. Circle. So here we can classify circles correctly. And again. So yeah, we saw together how to build a custom machine learning model that runs on this Sony Spresense board, and how to compile it directly from the studio. It will compile Edge Impulse SDK and a NuttX real-time SDK on the real-time operating system. Thank you for watching. If you have any questions, feel free to reach us on the Edge Impulse forum, so forum.edgeimpulse.com. Yeah, have a great day. Bye-bye.